I'm here with Roger Shropshire, the electrician for the University of Wisconsin-Whitewater, Residence Life, and I'm going to be asking him a couple of questions about our project, The System, which is a hydrogen solar generator for residential and small commercial use. Roger, good to have you here. Do you know of any competitors or anyone that produces a system similar to what I've described to you so far?
No, in pieces I've heard of it.
In pieces? Because we've researched a few articles that show that some universities have created like houses that run off of similar systems, but nothing like that's actually been commercialized yet, you don't think?
Not that I'm aware of, there may be. Who knows, it changes every day.
True enough. And like we were just talking about earlier, you didn't really allude to it. What do you think, or do you think this project is feasible, at least in terms of the cost of the technology and the size that I outlined to you?
Well, the size problem would be the PV solar panels.
Mm-hmm.
They're quite large and they don't put out a whole lot of power. So even on some commercial applications, they'll have banks of them, you know, so they bank them up, so you have, I believe, 10, you know, solar panels, or Sharp sells a package with 30, but these are quite large, you know, they're 2 feet by 5 feet.
Really wouldn't be practical for the size of the project we're pursuing right now?
Well, and I assume, you know, you're going to use the PV power to power batteries and store the energy, and then the batteries would be used to power a fuel cell to make hydrogen. The fuel cell part is small. Hydrogen powered prime mover for electrical generator would be small, but yeah, the PV cells are quite large, and I've never heard of them all being hooked together like that.
Okay.
It's feasible.
What if, provided that this was possible and we did put this all together in one unit about the size of a regular propane tank or the size of a regular desk, what would we need to do to make this safe to store outside? Like, is there any kind of weatherproofing or any kind of external, like exterior materials that we would need to put on here? Provided that this is all contained in one container, one package.
A lot of the smaller electrical generators, so the end product here is electricity, I assume, at 120, 240 volts, which you have in a house. And they make those generators. I have a generator at home like that. It's 5,500 kW, 5,500 watts. And that'll power, if I lose power, that'll run my pump. And I can run like the burners on the stove, it'll run my furnace. You gotta, be kind of spare in how you use it, of course, because if you overdo it, you're going to trip the breaker. What was the question?
just weatherproofing, like if we put this all in one package.
Yeah, okay, we'll get back to
anything
that.
special.
Those units, those small electrical generators, typically aren't weatherproof. And the literature I got with mine suggested making a little shed for it or something.
Okay.
Especially in cold weather, and a lot of times when it snows, that's when you're going to lose your power or something, and you got this thing sitting outside.
That's a good simple solution. I don't think we even looked at it that way.
Well, that's what they suggested. A 3-sided shed over the generator with plenty of airspace because it's air cooled. So yeah, that's one solution for that, I guess.
That's good. And you already talked about kind of the size of the operations. Let's see. Could you even just take a ballpark guess as to what sort of ratio of photocells to batteries we might need for this, provided we're powering like a small house like you were just talking about?
I don't know the requirements of a hydrogen fuel cell. And then of course you got to have storage facilities. A typical setup that they run now, and what they run now is they just have the solar panels, batteries, and inverter. Well, that calls for quite a few batteries and quite a few solar cells. And we're talking only like 20 amps maybe, a 20 amp setup, or 25 amp setup. You know, your typical house is 100 amps, 200 amps, which is a little overkill. I mean, you don't use that much typically. But, you know, if you're running a pump, a water pump, and you're drying clothes and you're cooking a meal, that takes quite a bit of power. And these systems are more on the lower end of that. So, you know, 20 amps. And that would be quite a few batteries and quite a few solar cells.
Quite an array of everything.
Yeah. Just the electrical portion of the project would probably, you know, the inverters, you know, 2 foot by 3 foot, and that's typically combined with a battery charger for the PV system. And then you have to have distribution panels, which, you know, are this big. And yeah, there's a space requirement for the electrical end. There's this definite space requirement for the battery end. You gain them up, and even a smaller system requires 200 amps DC, which is a lot of batteries, you know, and a significant cost, of course.
Well, let's move on here. 2 more questions and then we're done here. Do you know of any controls or like computer components or any companies that might produce computer components that we might be able to use in this product? Because that's something we haven't really nailed down yet. It's sort of
yeah, there's a lot of that.
aspect.
What you're talking about is an inverter charger.
Okay.
One name comes to mind, Xantrix is a real well-known quality outfit, and solar panels, Sharp is, I believe, the industry leader right now.
Is Sharp, is that the same company that makes TVs?
Yeah, yeah. So they're quite into it heavily, and well, I'll give you an idea what we're talking about here. You saw 30 of those Sharp solar cells, which put out quite a bit of power there. That's $22,000 for the solar cells. Mm. And of course, then you need brackets to mount them, and you need electrical wiring, take it down to the inverters. And, yeah, there's significant cost, which I believe is the only thing holding back a real development of this is the initial cost. And if you did a payout on that, you know, it would look real well. But interestingly, what the Germans have done, so like here in America, say we're paying anywhere from 7 to 12 cents per kWh on our electricity. When the Green Party was in power in Germany, they passed a bill that said that the utilities would have to pay back an individual energy producer at some astronomical rate. I don't recall exactly what it was. I think it was something like $60 a kWh or 80, which of course made it explode. And now I believe Germany is the biggest PV user in the world because of these reforms they made. That made it a real incentive for people to do it.
I believe it. And then one last question is, do you have any idea as to sort of the prices we might be looking at for some components? And I'll just name a few here. Let's see, you've already talked about the photocells, you've already talked about the converters. What about, I don't think we touched on lithium-ion batteries for use in the system.
I'm not all that familiar with the cost of lithium-ion batteries. There's all different kinds of batteries. Basically, the fancier they are, the more expensive they are. and I worked on electrical switchgear that had some pretty expensive batteries. Each battery, they come, they're not like your car battery. Your car battery has 6 cells, 2 volts each, that makes 12 volts. I mean, you may see that with 6 caps on the top. But on these bigger systems, sometimes they'll have just one cell that's, the dimensions are quite large, and that's a 2-volt cell. Mm-hmm. But that 2-volt cell costs you $400-something. For the typical, like home or whatever, one of the cheapest way out is like the batteries that they produce for tractor trailers. They're large, 12-volt batteries, huge. And because there's so many of them, there's they're cheap batteries. But then again, the performance isn't ideal for a storage system. What most people want is a deep cell battery, which of course costs more. And what that deep cell means is you can take it down to nothing and bring it back up, and the battery's constructed to take that.
I mean, like the charge, bring the charge down to...
Right, like if you wanted, you could use almost the full capacity of that battery, and then you fully recharge it. That's called deep cycling the battery. And to do that numerous times, the battery should be designed for that purpose. But like I said, you could get by with big truck batteries because you get the amp hour ratings, and if you didn't take them all the way down, you might be able to get away with that.
Well, those are all the questions we have. Your insights really helped. Thanks
Okay.
so much for meeting with me.
Good luck, make it, I'll buy one.